We'll work through some of these EOC problems so you'll know if you're doing the review correctly. So obviously I don't really know what's on the test, but I have a list of topics. They're called the standards that I'm asked to teach in Algebra 2. So I tried to put together a review of things that I thought could be possible test topics. So this first question says, what's the least common multiple? So if I think about a set of numbers, like let's say I was thinking about the numbers 3 and 5. If I wanted to find the least common multiple, I would think of the multiples of 3. They're 3, 6, 9, 12, 15, 18, 21. And I would think about the multiples of 5, like 5, 10, 15, 20, 25. So I'm looking at the factors, and the least one, the smallest one that they have in common is 15. So I would call 15 the least common multiple. So if I'm thinking about the least common multiple of these two polynomials, I want to factor each of them. And then I want to think about the smallest factor that they would have in common. So for this one to go into that, I would need this. And then I already have the factor x plus 2 here, so the other factor that I would have is x plus 5. So really the least common multiple is like when we were adding rational expressions and we were finding the common denominator. So let's find the least common multiple of this one. I need to know the factors first. So then the factor that this would go into is x plus 3, x minus 3. And the factor that this one would work with would be x minus 9 and x minus 1. So the least common multiple in this case was just everything represented. All right, let's look at the next question here. So simplify the expression. So I have a rational expression, and notice here I have multiplied. So I could solve this by multiplying straight across and then reducing at the end, but I'm going to reduce to begin with. So I'm going to start by factoring each part. This goes to x plus 3 and x plus 1. This doesn't factor. This doesn't factor, but this goes to x plus 3 and x minus 3. So now I'm going to look and see if there's anything that would cancel out in the numerator and in the denominator. The x plus 3's cancel, and the x plus 1's cancel. So my answer would be x minus 2 over x minus 3. Let's look at the next one. It's a different kind of problem. This one's subtraction. So I know with subtraction I'm going to have to get a common denominator at some point in time. So I'm going to start by making the subtraction and addition problem and changing that to -7. And then I'm going to factor each one of the denominators. So I'm going to make that x plus 6 and x plus 2. So I want to find the thing that this will go into and that will go into. I'm finding the least common multiple, which is the common denominator. So I need x plus 6 and x plus 2. Here I already have the x plus 2, so I don't have to add anything else. So I'm going to keep what's on the top. But here I was missing an x plus 6, so I have to multiply this times x plus 6. So it'd be minus 7x minus 42. Then I'm just going to put my like terms together on the top. 7x subtract 7x cancels. 5 subtract 42 is -37. So my answer would be -37 over x plus 6 times x plus 2. Okay, let's look at the last one. This one looks interesting because the denominators already look the same, except for this one is positive x, or positive 8, negative x, and this one is positive x, negative 8. So in order to make those look alike, I'm going to take out a -1 from this one, and I'll be left with -8 plus x. Or I could write it like this. -1 times positive x, minus 8. I'm going to rewrite that. 3x over -1 times x minus 8. You see how it's positive x negative 8 plus 7x plus 1 over x minus 8. So when I make my common denominator, I'm going to need a negative 1, and I'm going to need an x minus 8. This part isn't going to change. It's going to stay 3x. This part does change because from here to here, I've multiplied by negative 1. So I have to multiply the top times negative 1. So this would be minus 7x minus 1. So then add like terms, and I get negative 4x minus 1 over negative 1 times x minus 8. Okay, let's keep going here. So this section says solve for x. So I'm going to think about the fact that I have a log function. And so the way to undo or to solve a logarithm is to turn it into an exponent. So we talked about how this was the base, and it's going to become the base of the other side. So 512 equals 2x, and I'm going to put that in parentheses because I have to remember I want to take all of this base to the third power, not just the x. So 512 equals 8x cubed. Divide both sides by 8, and I get 64 equals x cubed. So x equals 4. The next one, I'm going to take 2 to the x power equals 32. So I have to think 2 to what power gives me 32, and that power is 5. And that's one we kind of have memorized because we see it a lot. The next one's a little different. This time, I have an exponent problem, so a lot of times if it's an exponent problem, we will log both sides. But I don't need to on this one because I can get these base values to be the same. This is 5 to the x power, and 125 is 5 to the third power. So now that I have both base 5, I can say that these exponents are equal. So x equals 3 times 2x minus 5. So x equals 6x minus 15. So negative 5x equals negative 15. So x equals 3. Okay, we'll finish out page 1 here. This time it says solve. I like this kind of solve problem because it's a single fraction on the left side and a single fraction on the right side. And if you'll remember, we decided we were going to circle anytime there was an equal sign because that means we can do something special if it's a fraction equals a fraction. In this particular case, we can cross multiply. So I can say x times x plus 7 equals 2 times 3x plus 10. So I cross multiplied only because there was an equal sign here. So x squared plus 7x equals 6x plus 20. So x squared plus x minus 20 equals 0. So that factors to x plus 5, x minus 4. So x equals negative 5, or x equals 4. I like the second one as well because looking at the sign, it's an equal sign, so that's good. That means I can cross multiply. So I'm going to put the 2 over 1. So I have 1 times this equals this times this. So 3x squared minus 3x plus 4 equals 2x plus 6. So 3x squared minus 5x minus 2 equals 0. So now I just need to see if I can get this to factor. And I know it needs to be 3x and x. And I think if I put the 2 here and the 1 here, this would be minus 6x and positive 1x. So x would be 2, or x would be negative 1/3. So those are the two answers.